Here we have a SAT math problem. Okay, let's go to the question. F of x equals to x to the fifth power positive k square times x cube positive 3kx negative 11. In the function f above k is a positive constant. If x negative 1 is a factor of f of x, what is the value of k? Okay, this is a problem based on factor theorem. Okay, first let's understand what is factor theorem. Okay, let's consider a polynomial function p of x and say x negative a is a factor of this polynomial function p of x. Let me write this up over here. Okay, when x negative a is a factor of this polynomial function p of x, we have to equate this x negative a to 0 and solve for x. When I solve for x, I'm getting x equals to a. Now, I have to plug in this value a for x over here into the polynomial function. When I do so, I'll be getting the result 0. So that is, this 0 represents a remainder when this polynomial function p of x is divided by x negative a. So only when I get 0 over here, we can consider this x negative a as a factor of this polynomial function p of x. In case if I get some other value other than 0, then this x negative a is not a factor of the polynomial function p of x. The same logic we have to apply in our problem. So the question says x negative 1 is a factor of the polynomial function f of x. Then what we have to do is we have to equate this factor to 0 and solve for x. Then I'm getting x negative 1 equals to 0. When I solve for x, I'm getting x equals to 1. Since it is a factor of f of x, when I plug in this 1 for x over here, then f of 1 must be equal to 0. Okay, now to get the stop for f of 1, I have to plug in x equals to 1 over here, here. I mean in the stop that is equivalent to f of x. Okay, when I plug in x equals to 1 over here, I'm getting 1 to the fifth power, positive k square times 1 to the third power, positive 3k times 1, negative 11 equals to 0. Okay, the value of 1 to the fifth power is just 1, and the value of 1 cube is just 1. 1 times k square is, we get k square. 3k times 1 is positive 3k, negative 11 equals to 0. Okay, here we can combine this 1 and negative 11, then I'm getting negative 10. Okay, now let me write it. K square positive 3k negative 10 equals to 0. Okay, here we got a quadratic equation in terms of k, and also this quadratic equation is in standard form, that is in the form of ax square positive bx positive c equals to 0. Okay, I think we can try to solve for k in this quadratic equation by factoring. For that, we have to multiply the constant term negative 10 by the coefficient of k square, that is 1 in this case. When I multiply this negative 10 by this 1, I am getting negative 10. Now, I have to get two factors over here so that the product of two factors is equals to negative 10, and the sum of the two factors is equal to the coefficient of k, that is positive 3. I think positive 5 and negative 2 will work. When I multiply positive 5 and negative 2, I'm getting negative 10. When I add positive 5 and negative 2, I'm getting positive 3. That is a coefficient of k. Further, I have to divide both these factors by the coefficient of k square, that is 1. Okay, even when I divide them by 1, still I'm getting a positive 5 and negative 2. Okay, since this is a quadratic equation, we may get two values for k. Okay, now to get the first value of k, I have to change the sign of the first factor over here. It's already positive 5. When I change the sign, I'm getting negative 5. Now to get the second value of k, I have to change the sign of the second factor, negative 2 over here. Since it's a negative, when I change the sign, it will become positive 2. Okay, I'm getting two values for k. One is k equals to negative 5, another one is k equals to 2. But according to the information, k is a positive constant. Since k is a positive constant, we can ignore this value because here the value of k is negative. So we can consider this one. Therefore, the value of k is 2.